So in order to quantify strain from time resolved CT data using feature tracking, we need this type of data where we have multiple phases over the whole cardiac cycle. And this is the raw 3D data. And from this, the first step would be to create reconstructions of a 2, 3 and a 4 chamber view. So I can load this into our 3D viewer application, and here you can create these reconstructions simply by using this simple NPR tool and making sure that you get the orientations in the right direction. So basically this is how you can do that. Let's say we have a 2-chamber view here. So here I can select it, change a bit the size, something like that. So when you're satisfied, you can give it a name and finish it and store it back. So I already prepared 3 long axis slices like that, and you can load these into the QMass application to get endocardial contours. So for instance, we can take a 2-chamber here and we can trace, for instance using a point mode, the contours in the end systolic and the end diastolic phase. So for instance this one. And you can still tweak the contours if you need to. So when you do that, I will show you how to do that for one long axis cine. You can do it for all 3. Basically then you load these into the strain application. So I'm loading here the 2-chamber and I'll show you some results. Here the feature tracking takes place, and from there we can quantify all kinds of parameters such as the endocardial global longitudinal strain. I've done this already for all 3, so I've prepared that here, and then you can see what it looks like in the different views, and you get a measure for global longitudinal strain, and also we can get a measure for global circumferential strain actually, because I will show you there is a 3D model of course, and from that we have 6 points. We can measure circumferential strain from these long axis images as well.